Imagine a place of almost complete silence, where the only sound is the whisper of wind across endless snow. A vast white desert sculpted by wind and time, stretching as far as the eye can see, untouched and pristine. This is Antarctica, the coldest, driest and highest continent on Earth, a land of extremes, both beautiful and forbidding. Here, a small group of scientists embarks on an extraordinary quest, not for riches but for knowledge and discovery. Bundled in high-tech clothing, they work against surreal ice formations and the profound quiet of the polar plateau, braving temperatures that can plunge far below freezing. Their mission is to journey back in time by drilling deep beneath the ice, unlocking secrets frozen for millions of years, secrets that could change our understanding of the world. Each year, new snow buries the old, compressing into ice and trapping tiny pockets of ancient atmosphere, preserving a record of Earth's past. By drilling into this ice, scientists retrieve a continuous record of Earth's climate, stretching back into a nearly unimaginable past, revealing patterns of change and stability. The work is slow and methodical, requiring patience and precision in a harsh, isolated environment where mistakes can be costly. Yet their determination is unwavering. Every core sample brings them closer to understanding the forces that shape our planet. They know the ice holds clues to how our planet works, how its climate has changed, and how our actions are shaping its future. Insights that are vital for all of humanity. Antarctica's frozen wilderness is more than a landscape. It's a library of Earth's history written in layers of ice. Their journey to the bottom of the world is a journey into the heart of our planet's story, a testament to human curiosity and the relentless pursuit of knowledge. What are these scientists searching for? Out here in the vast icy wilderness of Antarctica, teams of researchers brave extreme cold and isolation, all in pursuit of something hidden deep beneath their feet. Ice cores, long, slender cylinders of ancient ice, are their prize. Each layer in these cores is like a page in Earth's diary, recording the story of our planet year after year. The deeper the scientists drill, the further back in time they travel, reaching snow and ice that fell thousands, even hundreds of thousands of years ago, long before humans ever set foot on Earth. These frozen cylinders are true time capsules, preserving not just ice but also dust, volcanic ash, pollen, and even tiny bubbles of ancient air, all locked away for millennia. Each layer captures a unique snapshot of the environment, year by year, revealing changes in temperature, snowfall, and even major events like volcanic eruptions. The real magic lies in the minuscule bubbles of air trapped within the ice. These are perfect, untouched samples of Earth's ancient atmosphere, preserved exactly as they were. By carefully analyzing these bubbles, scientists can measure greenhouse gases like carbon dioxide and methane from the distant past, unlocking secrets about how our climate has changed. Ice cores provide the most direct, detailed record of how Earth's climate and atmosphere have changed together over time, offering insights that no other archive can match. Before the discovery of ice cores, our understanding of past climates was based on indirect clues, like tree rings or ocean sediments, which only told part of the story. Now, thanks to ice cores, we can literally hold a piece of ancient air in our hands, connecting us directly to the world as it once was. As Professor Eric Wolf puts it, there is no other archive on Earth that gives you such a direct record of the past atmosphere. His words capture the wonder and importance of this research. This direct link to the past makes the quest for older and deeper ice so compelling, driving scientists to push the boundaries of exploration in one of the harshest places on Earth. Retrieving these precious ice cores is a monumental feat of engineering and endurance. The process takes place in one of the harshest environments on Earth, where every step is a battle against the elements and the extreme cold. The Beyond Epica project, led by a dedicated team of European scientists, targets a remote and isolated site in East Antarctica known as Little Dome C. Here, the team has established a research camp far from civilization, surrounded by endless white. Years of careful research and satellite mapping identified this precise spot, where the ice is over 2.5 kilometers thick and ancient layers are perfectly preserved, offering a unique window into Earth's distant past. Drilling is painstakingly slow. A hollow tube methodically cuts around a column of ice, sometimes advancing just a few centimeters per hour. Each core is carefully brought to the surface, handled with extreme caution to prevent any damage or contamination. Once above ground, the ice cores are meticulously cataloged, labeled, and stored in insulated containers to protect their fragile structure. Scientists work in rotating shifts, braving temperatures that can plunge to -50 degrees Celsius, often spending hours in a trench carved beneath the snow, surrounded by silence and ice. Once extracted, the ice cores begin a complex and carefully coordinated journey, first by tracked vehicle across the frozen landscape, then by ship over icy waters, and finally by refrigerated truck to specialized laboratories in Europe, where they are never allowed to melt, preserving their ancient secrets. This logistical ballet, involving dozens of experts, ensures the samples arrive pristine and uncontaminated, ready for analysis. The effort, resources, and teamwork are all for one purpose: to push the boundaries of our knowledge about Earth's climate history. The previous record set by the original Epica project gave us an astonishing 800,000-year climate archive revealing patterns of ice ages and warm periods. But scientists have long believed that even older ice must exist, hidden deeper within Antarctica's vast ice sheets, waiting to be discovered. Now, Beyond Epica aims to drill deeper than ever before, reaching further back in time to uncover secrets from over 1 million years ago, reshaping our understanding of Earth's ancient climate. The Beyond Epica team has achieved a breakthrough, recovering an ice core that stretches back an astounding 1.5 million years. This nearly doubles the previous record and opens a new chapter in our understanding of Earth's history. To put it in perspective, 1.5 million years ago, Homo sapiens didn't exist, and woolly mammoths had yet to roam. This ancient ice is like discovering a lost book from a forgotten library. Scientists from 10 European countries collaborated to make this happen. Carlo Barbante, project coordinator, says this core will help us understand what forced climate changes in the past. The significance: for the first time, we have a direct, high-resolution record from a period of profound change. Why was this ancient ice so important? To solve the mystery of the mid-Pleistocene transition. For millions of years, Earth's climate swung between ice ages and warm periods, paced by a regular 41,000-year cycle. Then about 1 million years ago, the rhythm changed. Ice ages became longer and more severe, shifting to a 100,000-year cycle. The previous ice core record only showed us the world after this transition. It was like starting a mystery halfway through. The new 1.5-million-year-old core spans the entire transition. For the first time, scientists can analyze a continuous record from before, during, and after this critical event. They can directly measure greenhouse gases like carbon dioxide throughout this period. A leading theory, a gradual decline in CO2, pushed the climate system across a tipping point, triggering longer, colder ice ages. This ancient ice allows us to test that theory directly. The real magic of the ice core lies in the tiny bubbles of air trapped within. In cold labs, scientists carefully extract and analyze these bubbles, using mass spectrometers to measure ancient greenhouse gases. This gives us a direct measurement of atmospheric composition from 1.5 million years ago. By analyzing the ice layer by layer, we see how gases like carbon dioxide and methane have fluctuated over time. Previous ice cores revealed a clear relationship. When CO2 was high, the planet was warm. When low, the world froze. This tight coupling is fundamental to our understanding of climate change. Dr. Robert Mulvaney notes, "The ice core record shows us unequivocally that greenhouse gases and temperature are intimately linked." Now with the new core, scientists can see if this link existed in the older 41,000-year world. Did CO2 drop first, causing the shift, or did climate change for another reason? Answering this is critical to understanding the stability of our climate. Beyond air bubbles, the ice itself holds a wealth of information. Water molecules in the ice reveal past temperatures through their isotopic makeup, a natural thermometer preserved for millennia. By comparing temperature records with greenhouse gas levels, scientists see how the climate system works. The ice also contains physical clues, distinct layers, volcanic ash, and dust. Ash layers can be dated independently, verifying the age of the ice. Thicker ice layers mean heavier snowfall, thinner ones, drier years. Even the size of ice crystals tells scientists about past conditions. Dust in the ice reveals wind and aridity. More dust means colder, drier ice ages. By analyzing the chemical makeup, scientists can trace dust back to distant deserts. All these clues, water isotopes, air bubbles, dust, and ash, combine to create a rich, detailed history of our planet. It's a complex puzzle, but together, these lines of evidence reveal Earth's climate story. Studying ancient ice may seem distant from modern life, but it's vital for understanding today's climate change. Ice cores show the fundamental link between carbon dioxide and global temperature. For nearly 1 million years, CO2 naturally fluctuated between 180 and 280 parts per million. Today, due to human activity, CO2 has soared past 420 parts per million, a level not seen in millions of years. The ice core record warns us, when CO2 changes, climate follows. The mid-Pleistocene transition shows Earth's climate can cross tipping points and shift rapidly. By studying these ancient shifts, we learn about the risks we face now. The data from ice cores helps test and improve climate models, making future predictions more reliable. As Professor Anna Wolf says, understanding our past climate is key to predicting our future. The story of the ice core is a story of connection, to our deep past, to the forces shaping our world, and to our future. Scientists braving the Antarctic cold are guardians of our planet's memory, bringing its stories to light. Their work is a testament to human curiosity, collaboration, and hope. The journey of an ice core involves hundreds of people from many nations, united by a common goal. The ancient ice reminds us, our planet's energy balance is delicate, and greenhouse gases play a starring role. We are now altering that balance, but the story doesn't have to end in disaster. The knowledge we gain empowers us to make informed choices for a sustainable future. The Earth is our only home, its history, our history. By listening to these ancient stories, we learn not just about the world that was, but the world that could be. The challenge is great, but the story of the ice core is, above all, a story of hope.